Question 20. An object with a weight of 60 Newton is suspended by two lengths of rope from the ceiling. The angles that both make with the ceiling are the same. The tension in each length is 40 newtons. Determine the angle that the lengths of the rope make with the ceiling. So let's try to see how to solve this problem. Okay. So what I will do here is sketch the diagram to represent the situation. Now let us say that this is the ceiling, right? And from this ceiling we have two ropes. I'm using different colors here so that when we translate that into a vector diagram, you understand how, from where, what we are getting, right? So you can correlate the things. So that is the whole idea. So I'm using these three different colors. And then we will try to make a vector diagram from here. So what we are given here is, so this downward force, object with a weight of 60 newtons, so this is 60 newton for us, is suspended by two lengths of rope from a ceiling. The angle that both make with the ceiling are same. So this angle is also equal to that angle. That is what is given. The tension in each length is 40 newtons. So we have tension here, which we can say T1 and T2, which is 40 newtons. So this is what is given to us, right? So let's call this tension as T1 and this as T2. Determine the angle that the lengths of the ropes make with the ceiling. So we have to find what these lengths are. So the diagram which I just made is called the position diagram. Now from here we will draw the vector diagram and then find the answer, correct? Now to draw the vector diagram, there are many options. So what I will adopt is, I'll start from this point, right? So I'll draw this line and then we'll translate this tension over there. As you know, the vectors can be translated in space, correct? So that is how I'm going to do. Have a look at it. So I'm just drawing this line. So I'm just drawing it here for the time being, which is kind of like this. Is that okay? So this line is parallel to that, correct? That is tension T1. Now, so at this position, I will draw tension T2, which is parallel to this, and that is how it is, correct? Now, if the system is in equilibrium, then the resultant force should match the 60 Newton. And therefore, we draw from here, I may have to extend it, but what I'll do is I'll reduce this. So the resultant should be equal to 60 newtons to make the whole system in equilibrium. That is kind of most important, and that is how you get your vector diagram. So this is 60 newton for us. And these two forces, which is T1, that T1 is 40 newtons, and that is also 40 newtons, and that is T2, right? It's kind of important for me to label since both are same. So if I write T1, T2, you know exactly what I'm doing, right? Now this angle, as you can see with the ceiling, so why I have drawn this dotted line? To show you the ceiling, right? So with this ceiling, we have theta here and theta there. So basically it becomes 2 theta. And that is the angle which we need to find, correct? So now in a triangle, you are given 3 sides. So if you are given 3 sides, how can you solve this triangle? You guessed it, right? It can be solved using cosine law, correct? So we can use cosine law and solve this triangle. I hope you remember what cosine law is. Now, one way is that you can use cosine law using this angle theta, right? And rather 2 theta, right? So when you get your answer for theta, divided by 2, get your answer. That is probably the best way. Or what we can do is we can use this angle. Let us say this angle is phi. In that case, we can find phi, and you know this is 90 degrees. And from there, we can do 90 minus phi to get the answer. So that's the other way to do it, right? Either way will work. But in most of the tension problems which we have been dealing, we have been using this angle, correct? Most of the time. So in this case, we have both the options. But however, I'll prefer to use phi itself, right? So that is the strategy for me. So it's very important for me to explain and share with you our steps. So this is phi for us. We say cos phi is equals to. I'm not writing cosine law. When you're preparing for test, I think you know all those things, right? But I'm trying to show you how to remember it. When we are dealing with this angle, then we add squares of these two, which are on the side. So we have 40 square plus 60 square minus the opposite side square, minus 40 square. So that ways you can easily remember how they are related. Do you understand? And it is 2 times 40 and 60. These two. 40 and 60. 2 times 40 and 60. So that is how you can say, basically, you can remember how to correlate. It's kind of very important. So you do all this math, and of course, phi is equals to cos inverse of all this, right? So cos inverse of all this, right? So I'm not copying all this, but you understand what I'm trying to say, right? Use your calculator, find cos inverse of all this, and once you do that, you will get, I think, 41.41. This is what you're going to get as angle phi, correct? So when I'm saying this, this is like 40 square, okay, let me write, plus 60 square minus 40 square, so which cancels out, right? Times, I'm not cancelling anything, I'm just keeping the figures as such so that you understand why and from where what is coming. So 2 times 40, 60, do you see that? And these are that. So easy calculations though, you get phi. So you want to know what these angles are. So sometimes those angles are different, and that's why we took this approach. In this particular question, both were same, so it was simpler. Anyway, so you could have mixed them up. See, now the theta is, in this particular triangle, if you see, 90 minus phi is theta, right? So we'll say 90 degrees minus that 41.41 degrees, and then you get your answer, which is 48.6 degrees. Do you see that? So that is how you get, and since both the angles are theta, then you can say, determine the angle that lengths of rows make with the ceiling. So write down your answer very clearly. So the answer is, angle with the ceiling is 48.6 degree each. So each makes that angle set both. So that is how I think you should solve the question. Now let's have a recap on this. When you read your question, read properly, write down what is given to you. Then make a neat sketch. Now I have used colored sketch only to show you from where what is going. You don't have to do all that. So this particular diagram is called position diagram. It really shows you exact position where what is, right? Now when we are trying to solve this, then we have to represent this in a vector diagram, right? So this is our vector diagram. And what the concept here is that if the system is in equilibrium, then that is a resultant. So this is a resultant R, which is equal and opposite to 60 Newton, and therefore that direction R. I hope you understand. And this, right? So what we did was we translated our forces or tensions, as you can see, T1 and then this T2, and that triangle completes resultant, right? Now if T1 plus T2 equals to R, then the system is in equilibrium. Since we were given 3 sides, we used cosine law to find the angles, right? And that is how we worked out. I hope it clears all the doubts in your mind. Thank you and all the best.